In this video, we're going to take a look at applications of normal distributions. In particular, we're going to look at working with normal distributions that have not been standardized, so they have a mean that is not 0, or a standard deviation that is not 1, or both. And when we do these things, we can standardize these normal distributions by finding a z-score. So recall that a z-score is equal to a data value minus the mean divided by the standard deviation. Right? Or we might write that as x minus mu over sigma. And so we will use this z-score quite a bit, or some version of this z-score formula. We will use the same process that we had before when we use StatDisk. Again, StatDisk is an online program by Triola that's associated with the Triola series. If you are using his textbook, that is free to use at statdisk.org. And so we will go there. If we want to calculate a probability that's associated with a normal distribution, we will first take a data value and compute the z-score. We'll do that by hand. Then after we calculate that z-score, we'll go to StatDisk and we will go through a variety of steps. And it will spit back some values that we can read off. We have a little bit of strange things going on if we're trying to find probabilities between two values. So if we want probabilities between two values, then we need to convert both of the values to z-scores, find the area to the left of both or to the right of both, and then we'll take the difference between those areas. If we want to go the other direction, we plug in the area to the left of the desired data value. We identify that. We go to StatDisk and plug it in, and then we calculate the z-score. Once we have that z-score, we convert the z-score to a data value using this manipulation of that z-score formula. Let's look at an example to see how these things work in practice. So here we have our example. Men's heights are normally distributed with a mean of 69.5 inches and a standard deviation of 2.4 inches. So for men's heights, we know the mean is 69.5. We know standard deviation is 2.4. How do we know it's a normal distribution? Because it says it in the problem, right? So it's normally distributed. Women's heights, they are also normally distributed. Their mean is 63.8 inches. Their standard deviation is 2.6. The U.S. Navy, they require pilots to be between 62 inches and 78 inches tall. We are going to solve, draw, and shade the problems below. And so here we want to find the percent of women that meet the requirement. And so in words, what we are, or in a picture, what we are looking for is we are looking for women's heights are normally distributed. The mean height for women was 63.8. So we want to know what percent of women, what's the area under the curve for women with heights between 62 and 78. So from 62, which is somewhere to the left of 63.8, up through 78, we want to know what is that area under the curve. So the way that we're going to do that is we are going to convert 78 to a z-score, and we'll convert 62 to a z-score first. So the z-score for 78, right, so our z-score for 78 z is equal to the data value, so that's 78, minus the mean of 63.8 over the standard deviation. The standard deviation for women's heights is that 2.6. So we have 78 minus 63.8 divided by 2.6. And when we do that, we get something like 5.46. We will also convert the other data value, the 62, to a z-value as well. And so here, if we convert 62 to a z-value, we'll take 62 minus 63.8 over 2.6. And if we do that, we get a z-value that's negative 0.69. So now what do we want to do with these? Well, we're going to convert both of these z-values to areas. And that's not something we can do on a calculator. We can't do that with a simple formula. We're going to go to StatDisk, and we will use StatDisk to calculate that. And so we're going to use 5.46. We will find, let's find the area to the left of the z-value 5.46. So we're going to go over here to StatDisk. We are going to choose Analysis, Probability Distributions, Normal Distribution. We have our z-value of 5.46. And when we evaluate that z-value, we get an area to the left is 1.0, and area to the right is 0.0. So let's deal with areas to the right. So the area to the right of a z-value of 5.46, an area to the left, the area to the left of a z-value of 5.46 is 1. So the area to the left of this is 1. The area to the left of a z-value of negative 0.69. So we're going to come back to StatDisk. We're going to plug in a z-value of negative 0.69. And when we evaluate that, we find the area to the left there is 0.2451. If we go to 4 decimal places, 0.2451. And so if we want to know what is the percent of women that meet the requirement, we're going to take the difference between those two areas. So we're going to take 1 minus 0.2451. And if we do that, we get 0.7549. This asks for the percent. So as a percent, that is 75.49% of women, they meet the requirement. Next, we want to ask a similar question, only this time we're going to say what percent of men meet the requirement. So again, we have a normal distribution. This stuff is going to look very similar, except for we're going to use the information associated with men. And so the mean height for men is 69.5. We want to know from 62 up through 78, what percent of men fall in that range. So we're going to take 78 and convert that to a z-score. But this time we're using all of the information that's associated with males. Right? So 78 minus 69.5. divided by the standard deviation for men, that was that 2.4 instead of the 2.6. So 78 minus 69.5 divided by 2.4. And when we do that, we'll get 3.54. Remember, that's a z-value. That is not an area or a probability yet, so we're still going to have to do some other calculations with that. We won't be done with that. For 62, the z-value is 62 minus 69.5 over 2.4. When we find that z-value, we get a z-value of negative 3.125. I guess if we round to 3 decimal places, it'll be negative 3.13 if we round to 2 decimal places. And then we're going to take each of these and we're going to go to StatDisk. We will find the area to the left. Right? So these are z-scores. We won't ever subtract z-scores from each other. Here we're going to convert those to areas. We will subtract areas. Those are probabilities. So to the left of 3.54, we're going to enter in a z-value of 3.54. And when we do that, we have an area to the left, if we go 4 decimal places, 0.9998. And for negative 3.13, we're going to do the same thing. We're going to enter that z-value, negative 3.13. Evaluate, find the area to the left. That is, if we go to 3 decimal places, 4 decimal places, 0.0009. And finally, we are going to take the difference between these two values. So we're going to take 0.9998 minus 0.0009. And when we take that difference, we get 0.9989, I suppose. This asks for the percent of men. So the percent of men that meet the requirement is 99.89%. Perfect. All right. So those are the percents. That's how we can go from data values to percents. We have one more question in this part. This last question is a little bit different, so let me address that in a different video. We will see you there.